Hey guys, welcome to Chapter 7 of the Algebra 1 program. Congratulations, you've made it to Chapter 7. All right, we are in Section 1, and in this section, we are not really going to learn anything new, but we're going to apply it in a new way. And it's going to be an enormous reinforcement of what we spent all last chapter doing. So I don't know if this is good news or bad news, but this is our last section of graphing for the next little while. So if you've loved graphing, I'm sorry to hear it. If you've hated graphing, well, hang on, and you're almost done for just a little bit. So in the last chapter, we learned how to graph functions in a whole variety of forms. And we learned that the best form for us in order to be able to do so many things was in y equals mx plus b form. Y equals mx plus b form. We loved that form because we had our y-intercept and we had our slope and we could graph this thing easy peasy. We're going to utilize that, but we're going to step it up a notch in this section. In this section, you're going to be solving systems of equations by graphing. So this is going to be the first of 3 tools that we're going to teach you as a system of equations. But what is a system of equation, you ask? And so here I've defined it for you. It is multiple equations in the same problem that are operating together somehow. And for our purposes, what we're looking for is the intersection of 2 lines. So for us, we're looking for the intersection of 2 linear lines. Remember, linear has that root word line in it. All right, and in order to be able to do that, basically we need 2 functions and then we need to graph them and see when they intersect. So without further ado, what if we have x plus y equals 4, and then we have the line x equals -1? Well, the second equation is pretty darn easy, right? So it's the line that goes through the point x equals -1. So there we have our second line. And now we just have to work with the first. So again, like I just said, we'd like everything in the form y equals mx plus b. So I'm going to solve this guy for y. And I'm going to get y equals -x plus 4. All right, so we always start with the y-intercept, 1, 2, 3, 4. And then we have a slope here of -1. So from this point, I'm either going to go up 1 and over 1, or I can go down 1 and over 1. But remember, this has a negative slope. So this guy better be running up and towards the left. All right. I'm going to try to align my ruler, which is, trickier than it may seem. And you find the point of intersection, which is right there. That is the point -1, -5, or +5, excuse me. -1, +5. This is the solution to this system of equations. All right, remember, math is its own language here. So it's really important that you understand what we're saying when we say it. So this was our system of equations, and this is the solution. The solution because it fits in both of our functions. Okay, actually at the beginning of your assignment today, you're going to have to practice plugging in a point and seeing if it works in both equations. I'm not going to do that for you here because we're starting to progress and mature in our math curriculum, and I trust that you'll be able to figure that out really quickly, and it should be easy for you. But I'm graphing those same equations that you're going to test, so if they look familiar, that's why. But what you're looking for is that this point works in both functions, okay? And for us, it does. All right, let's move on to another example. What if I have y equals -x plus 4, and then y equals -1/5 x? I want to find the solution, all right? And the solution is our point of intersection. So we're looking for the point of intersection here. Well, both of our functions are already in y-intercept form. That makes us super happy, and so we can just jump in and get going. So for our first function here, we'll call this one number 1. My y-intercept is 4. So I'm always going to start at 4, the y-intercept here. And then my slope is -1. So I'm going to go up 1 and over 1, up 1 and over 1. Or if we're practicing being careful here, we can go down 1 and over 1, down 1 and over 1. All right, so get your straight edge and draw your line. And now let's work on equation number 2. Equation number 2 has 0 for its y-intercept, right? So when there's nothing there, we assume it's 0. So that means I'm going to start my graphing at y equals 0 here. And then my slope for this equation is -1/5. So I'm going to go up 1 and over 5. 1, 2, 3, 4, 5. All right, and then I could go down 1 and over 5. 1, 2, 3, 4, 5. And you're going to see, obviously, I didn't draw this quite far enough here. All right, now we're looking for that point of intersection. And that's going to happen down there. That is the point 5, -1. So the solution to this system of equations is 5, -1. All right, you getting the gist of this? Okay, let's do another one. I'm going to throw in a few special cases here for you. What if I have y equals -3x minus 4, and then 3x plus y equals -4? Let's jump in. Equation number 1. We start at -4, and then our slope is -3 over 1. So 1, 2, 3, and over 1. 1, 2, 3, and over 1. That should be pretty straightforward here. All right, so we can graph that up, draw our line. We're good to go. All right, what about equation number 2? It's not in y-intercept form, so let's do that. So we're going to subtract 3x from both sides. And now it is in y-intercept form. All right, again, I'm going to start at the y-intercept, which is -4. And then my slope is -3. So -3 over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. Wait a second. That's the exact same line as my first function. In a case like this, where you actually get the same graph or the same line, this is called an infinite amount of solutions. Why is it an infinite amount of solutions? Well, because every single point on this line matches, right? It's going to go through both functions. So no matter what, they're always going to match, right? So there's an infinite amount of solutions. So when it's the same line, it's an infinite amount of solutions. Okay, let me give you another scenario. What if we had y equals -x plus 2, and then we had 3x plus 3y equals 12. Okay, the first function should be easy peasy. We're going to start at 2. We have a -1 slope, so we go up 1 and over 1, maybe down 1 and over 1, and life is easy and good. All right, equation number 2, it's not in y-intercept form, so let's do that. 3y is going to equal -3x plus 12. And then remember, I have to divide everybody by 3 here. Just in case you forget, y equals -1x plus 4. All right, so let's graph this up here at 4. I'm going to go up 1 and over 1, up 1 and over 1, down 1 and over 1, down 1 and over 1. Get your straight edge. Okay, and what we observe here, we kind of touched on at the end of our chapter 6. We've got two lines that have the same slope, that also have different y-intercepts, that makes them parallel lines. And what do we know about parallel lines? They never cross, right? So parallel lines never cross. And if they never cross, then this one is no solution. Right? So we were looking for the place of intersection. But if I have parallel lines, then they're never going to cross. And therefore, there's going to be no solution. Okay, you guys, I hope this is pretty straightforward. It's just practicing those skills that we learned last chapter and then looking for the point of intersection. So hopefully you won't struggle too much. But I want you guys to finish up your notes, read through the section, and begin your assignment.